Now let's go through the correction of the homework from Friday. And we had question 10. We were asked to find the values of x and y in these triangles. So because we have an isosceles triangle here, this angle down here is 32 degrees, which lets us find the value of x. 180 minus 64, which is 116. So x is equal to 116. X is supplementary to the angle down here. So this is also 64. You could have worked that out by saying it's the external angle, so it's those two added together. And this is isosceles, so this is 64. And y is going to be 180 minus twice 64 minus 128, which is 52. So y is 52. Okay, over here, all we have is a triangle with unknowns in every step. So what are we going to do? Well, look inside the triangle first of all. They're all in terms of x. So we know that the three of those add up to give me 180 degrees. 3x plus 2x plus 4x, which is 9x, is equal to 180 degrees. So x is 20. This is 20 degrees. X is 20. Then you could do it by the external angle and the two angles here, or we can do it by supplementary angles. 2x, of course, must be 40. So y plus 40 adds together to give me 180, and y is 140. I should put in my degree symbol, because that's what we're dealing with here. I don't think they'll actually penalise you if you don't, though. Y is 140 degrees. Over here, these dots here mean that these two angles have the same value. I have an isosceles triangle down here. Those two sides are the same. So those two angles are the same, and this dot is 50 degrees. So this is 50 degrees. And we can use that information in this triangle to work out x. So 50 and 50 is 100, and x must be 80 degrees. Then the other side of x must be 100 degrees. Now if I have 100 and 50, y must be 30 degrees. So y is 30. That was a bit fast, so if you don't understand what I did there, just let me know and I'll go through it more slowly. Okay, so using our facts about triangles to find missing values. Now, down here we're going to use the Theorem of Pythagoras. So the Theorem of Pythagoras tells us that the hypotenuse squared is the other two sides squared and then added together. The important thing about this is correctly identifying your hypotenuse. The other two sides don't matter. So here my hypotenuse is x. X squared is equal to 6 squared plus 8 squared. So x is going to be the square root of 36 plus 64, which is 100. X is going to be equal to 10. X is 10. Might need a little bit more room for showing the workings out for these. This one, the hypotenuse this time is 13. So y squared plus 12 squared is equal to 13 squared. The important thing and the mistake that people make is that they want to put the unknown value in this place on its own every time, but that's not always the case. When the unknown value is one of the shorter two sides, then it's going to be added together to the other shorter side here. So what we get is y squared is equal to 169 minus 144. Y squared is 25 and y is 5. So here y is 5. This one, the hypotenuse is 17. So z squared plus 15 squared will give me 17 squared. Put that in up here. Z squared plus 15 squared is 17 squared. So z squared is going to be 17 squared I don't know this one off the top of my head. 17 squared, and that is 289. 289 minus 15 squared, which is 225. 225. So z squared, 289, is 64, and z is equal to 8. So they all worked out nicely, and they won't always, but they did in this case. So z is equal to 8. Okay, find the length of the side AB in this right-angled triangle. Let's call it x, because we don't know it. This is my hypotenuse. The longest side is always the hypotenuse. So the two other sides, x squared plus 4.5 squared, is equal to 7.5 squared. X squared is 7.5 squared. And I might just do this in my calculator in one step. 7.5 squared minus 4.5 squared. So you can just do that and write down the answer. And that's 36. So x is equal to 6. They didn't give me any units. So centimeters, meters, we don't know. The length of the side AB is 6 units. Hence, find the area of the triangle. So area is half the base by the perpendicular height. So that is half 4.5 by 6. Just put that into our calculator in one go. A half multiplied by 4.5 multiplied by 6. 27 over 2, or 13.5 square units. Units squared. We don't know what the units were. You won't be penalised if you leave them out if the question didn't specify. They almost always do in the leaving cert though. Okay, question 13. In the given figure, the angles ACB and ABD are both right angles. They're marked in, that's fine. If AC is 3, CB is 4, and BD is 12, find AB. That's the hypotenuse on this smaller triangle here. So let's do that. H squared is 3 squared plus 4 squared. So H squared is, do those in your calculator, 25, and H is 5. So the length of AB is 5 units long. 5 units long. Could be centimeters, could be meters, we don't know. And find the length of AD. So now we know that this is 5, and we want to find this, and we're just springing along our right angle triangles because this is the hypotenuse. It's across from the right angle in this one. So H squared is equal to 5 squared plus 12 squared. H squared is 169, and H is 13. So the length AD is 13 units. Okay, hopefully those made sense to you, but let me know if there was any step that you didn't understand. 16 and 17, congruent triangles. Explain why the two triangles below are congruent. Well, they're right-angled triangles, so we're going to look for RHS. We write down each of those in turn. They are right-angled. They're both right-angled. H, their hypotenuses are the same length. Hypotenuse are the same, I don't know how you pluralize hypotenuse, are the same length. And do they have a side in common? They do. They have a side that is also the same length. Also the same length. Okay, So that's my explanation there, the RHS. Same kind of question here in question 17. ABCD is a parallelogram. And can we explain why the triangles ABD, this one, and BCD are congruent? Can we explain that? Well, what do we know? In a parallelogram, we know that opposite sides are equal in length and opposite angles are equal in size. But also, this dividing line here from B to D is a shared line, so it's the same as itself. So they're congruent by side, 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 three sides in common. First of all, AD is the same length as BC because they're opposite sides in a parallelogram. Also, AB is the same length as DC because they're opposite sides in a parallelogram. And finally, DB is the same length as itself because it's a shared side. So that's why the triangles ABD and BCD are congruent. And there's our explanation. Do you have to write it down mathematically? No, you can write it down in sentences, but it's usually quicker to write it down mathematically like this. You definitely get marks for work shown on the diagram as well with these. Okay, let me know if you have any questions about that, and we'll move on to the next part of geometry now.